part A talked about show that 1 over 2x minus 1 plus 4 over 2x minus 1 square can be written as 2x plus 3 over 2x minus 1 square. So in this case, in order to show that, so I'll just take the left-hand side or this expression. So 1 over 2x minus 1 plus 4 over 2x minus 1 square. So in this case, I have to think about making the same denominator. So in order to do that, I'll just multiply for the first term, both the numerator and the denominator with 2x minus 1. So when I do that, so on the numerator, I'll just get 2x minus 1. And on the denominator, it's going to be 2x minus 1 squared plus 4 over 2x minus 1 squared. So now, because the denominators are same, so I can add or subtract the numerator. So in the numerator, it's going to be 2x. Then minus 1 plus 4 has to be just plus 3 and divided by 2x plus 1 squared. And now, using this is what we need to solve part B. So part B is nothing but find the integration of 2 to 5. And of course, this is just a one marker, getting this step correct and showing basically this main step, that is we are making the common denominator and adding the numerator. Getting that step correct, showing that particular step can award you 1 mark. If I talk about part B, so find the integration of 2 to 5 of 2x plus 3 over 2x minus 1 square and give the final answer is in the form of a plus ln b, where a and b are constant. So now in order to do this, so first of all, there is no way that you can differentiate, you can integrate this directly. So you have to use part A's result. So that's why they have given part A here. So now 2x plus 3 over 2x minus 1 square can be written like this. So in that case, I'm going to rewrite the integral expression as 2 to 5 of 1 over 2x minus 1 plus 4 over 2x minus 1 squared. And I need to integrate this with respect to x. So in that case, I have to rewrite this 4 over 2x minus 1 squared. So integral of 2 to 5 of this one, I'm not going to take it to the numerator because we have the direct integration rule for 1 over linear function. Plus, this is going to be 4 into. So whenever I have some power in the denominator, any exponent with a positive power in the denominator, and if you are taking it to the numerator, it will become a negative exponent into dx. Now we can integrate that. So integration of 1 over any linear function would be ln of 2x minus 1. This is the rule that we should be aware of. And divided by the coefficient of x, that's 2. Then plus 4 times integration of any linear expression to the power of n would be the same linear expression to the power of n plus 1, which is minus 2 plus 1, which is minus 1, and divided by minus 1 and multiplied. But of course, so you basically divide by so the coefficient of x, so that's basically 2. So here we can simplify a few things. Okay, and we need to apply the limits here, so which is 2 to 5. And whenever we think about applying the limits, we should always apply the upper limit first, then the lower limit. So when I apply the upper limit, so which means in place of x, I have to substitute 5. So that's going to give us ln of 2 times 5, which is 10. 10 minus 1 is 9. So ln of 9 over 2. Then plus, oh, this has to be minus. I'm just subtracting it. I'm just dividing it with over minus 1. That has to be minus 2 times. 2 times 5 is 10. So 10 minus 1 is 9 again. So minus 2 times 9 power minus 1. And this is what would be my expression would look like after substituting the upper limit. then it's always upper limit minus the lower limit. The lower limit is 2. So when I substitute 2 in place of x, so that's going to be ln of 2 times 2, which is 4. So 4 minus 1 is 3 and divided by 2. Then this is again minus 2 times 2, which is 4 minus 1, which is 3 to the power of negative 1. And we just need to simplify this. ln 9 can also be written as ln of, okay, let's keep it as it is. So ln 9 over 2. And I'm going to group this. Okay, let me write this one as minus 2 over, if I have 9 power negative 1, so that can be written as 2 over 9 power 1 and minus ln 3 over 2. Then I'll be having positive 2 over 3. So now, in order to simplify this, so what I should do is, I have to simplify these two expressions. So in order to make the common denominator, I'll just multiply it with 3 and 3. So it's going to give us negative 2 over 9 plus 6 over 9. And here, the common denominator is already 2. So that's going to give us ln of 9 minus ln of 3. So when we simplify this, so this is because I have the common denominator, I can add the numerator directly. Minus 2 plus 6 would be 4. So I'll be getting 4 over 9. Plus this is going to be 1 over 2 times ln of. So we know this ln of m minus ln of n. That's going to be ln of m over n. So which is nothing but ln of 9 over 3. So 9 by 3 is just 3. Now this still doesn't look like that format because there is no coefficient for ln here. So which means I need to take this half inside the ln. So that means I need to write my final answer as 4 by 9 into 4 by 9 plus ln of 3 to the power of half, or I can say 4 by 9 plus ln of 3 to the power of half is nothing but root 3. And here A and B are constants. So they never said it has to be a rational number or something. So it can also be an irrational number. So when I compare it, in place of A, we have 4 by 9. And in place of B, we have root 3. And this is the final answer for the sum. So the mark distribution for the sum goes something like that. So now using this format can get us 1 mark. And getting the integration correct, so can give us another mark. And now substituting the upper limit and a lower limit, that's showing that we have substituted it. So this is going to give us a 1 more mark, so which is 3 mark till here. And from here, simplifying it and getting the final answer correct can award us 2 marks. And this is how the mark distribution for this particular sum goes like.